I've got some interesting time. I think we're just gonna start to convene. I know people are still going to be rolling in, and in fact, one of our speakers is still going to be rolling in, and we have a time to see if they're going to make it in time for their talk. It's nice to see everyone here for day two. You don't really hear a lot from me. I look forward to learning more about this area. Our first speaker is Dr. Yang Lu from Emory.
Thanks, Chris. I do this.
Just the arrows on there, and then it's the laser. And I don't think you'll need the mic because those guys pick it up.
So I can just walk
Yeah,
around.
you stand, yeah, but on the side of the table or behind it, either way.
Can everybody hear me?
Yeah.
On live, folks. You can hear me.
We had no complaints yesterday, so we should be good, but.
Okay, so. Awesome.
There we go.
Good morning, everyone. It's my pleasure to share our project with you. This is about developing a set of wildfire smoke PM 2.5 in the continental US for different potential downstream uses. I think I'm going to skip this background talk because everybody is aware of the importance and potential impact of wildfires. It's either in the air quality context or in the climate change context. Now, our goal is to estimate long-term smoke PM 2.5 in the continental US. And the reason for that, as opposed to a more intensive detailed study of a potential episode, is that we believe wildfire smoke, at least in the Western US, has become a chronic problem for air quality and health. The fire season on the West Coast now starts in February and ends in November. It's pretty much a year-round thing. It's almost a fire year now, not a fire season anymore. And that brings up the hypothesis or assumption that we should be able to see, or we might be able to see more severe health effects due to chronic exposure to fire smoke instead of, acute exposure for a couple of days. So that was our goal. So this is one of the fusion methodology. We bring in satellite data, CMAQ simulations, NOAA HMS, fire contours and smoke density estimate, cloud fraction for gap filling, and then a bunch of land cover and other proxies for anthropogenic sources. And the idea is we grid everything and make predictions at 1 kilometer spatial resolution at the daily level. So this is our methodology. The idea is, okay, we defined fire impacted, smoke impacted region, build a model in that region, and if the rest of the country is considered not affected by smoke, we build a model there and then extrapolate into the smoke impacted region to generate a background. And then their difference is the smoke contribution to the PM2.5. To accomplish that, there has to be a set of models. So we have a fire model, we have a non-fire model. They follow the general modeling framework, except that in the fire model, we integrated HMS, fire contours, and then the CMAQ total PM simulation. For the non-fire model, we only included the CMAQ background PM simulation. And then at the grid cell level, total PM is background plus smoke PM. Non-fire grid cells, we only have background PM. So we're able to separate the two sources. Without going into a whole lot of details of how we construct the random forest model and then all the gap filling to eliminate the data gaps, data holes caused by satellite AOD. I'm showing directly the model performance metrics at the daily and monthly level. The top panel shows the fire model, and then the bottom half shows the non-fire model. The training data sets were constructed so that the daily training sample size is roughly equal for both the fire and non-fire model. So we wouldn't have to deal with the issues of undertraining a particular model in the random forest algorithm. They're either both fully trained or both undertrained. Okay. And if we look at the cross-validation R-square values, we did random, spatial, temporal cross-validations. Model performance are comparable. Of course, the fire model sees higher PM levels. The non-fire model has a narrower dynamic range of PM concentrations that affects the population level model performance metrics such as R-square and root mean square error. It's just it's a naturally happening effect for this type of performance evaluation. To give you an example of the final predictions, this is at the daily level. This is I believe this is a VIIRS imagery on August 1st, 2008. This is considered a large fire year. And then the red dots are satellite detected active fire spots for large groups of fires. And the contours are manually drawn HMS fire smoke contours, meaning after consolidating all the satellite imagery, a NOAA analyst determines that within the contours are fire smoke prone region. Right, so these are actually manually drawn, very labor intensive, and we use that as an indicator of the smoke impacted region. So it's a binary indicator instead of using HMS data directly in the model development. So you can see the kind of some of the granularity of the model prediction. The highest level we predict is on this day at the 1 kilometer spatial resolution is about 365 grams per cubic meter. And the smoke transport went all the way from the West Coast to the East Coast. And this is smoke specific PM 2.5 predictions. It generally follows the contour as a companion to the HMS smoke impact indicator. We also did a threshold on the CMAQ simulated fire smoke contribution. We set it at 3%. If 3% of the total PM 2.5 is from fire, according to CMAQ, we consider that pixel smoke impact, smoke affected pixel. So it's a combo of the two criteria to determine the fire impacted region for model development. And this is the annual average. That's total PM concentration. And this is the smoke PM 2.5 at the annual average level in 2018. And to my surprise, that we see large regions affected by fire smoke outside Western US. And then I dug a little bit deeper and realized that in 2018, in Texas, there were at least 800 wildfires that year. And then there were large wildfire events in Canada, and from the Pacific Northwest, the plume went all the way to Kansas. And also in March, there are multiple large fires in Florida, as we can see right here. So it wasn't just a wild speculation that wildfire is only a West Coast thing. This is at the annual level. And if we further consolidate and estimate the number of days with at least 25% smoke contribution at the zip code level care about population, right? So there are unpopulated regions that are blank. From here, we can say, yeah, of course, on the West Coast, there are up to, let's say, 200, 300 days when smoke contributions were greater than 25% to the total PM2.5. Even on the West Coast, we have somewhere like 50 days, something like that, where smoke is a major contributor to the elevated PM levels. And here, if we aggregate at the temporal scale, we can say this is the daily national average proportion of smoke impact in the continental US. And we can see that during the fire season, it can be almost 40% of the entire country was affected by smoke, right? So it's also a year-round thing, started in March, and in this particular year, it's pretty much ran all the way to the end of 2018. So this is kind of the first step, and I think we are successful in developing this full coverage, just every day, 100% coverage, high performance modeling system to estimate smoke PM. If we can include other fire years, say 2020, so that we can factor in more of the local sensor data to capture the high end of the PM concentrations, model performance is expected to further improve. And then we conclude from analyzing that multiple 12 years of data, wildfire has become a major source of PM pollution in the US, especially in the West Coast, of course. And during a large fire year like 2018, CONUS as a region has been affected. Of course, there are some limitations, especially on the computational and model simulation side. That's all I have. Thank you very much.
Great talk. I think we'll probably hold major questions to the end, but if there's a clarifying question. Then next up is Jingqiu from the University of Alaska Fairbanks.
All right, thank you very much. Good morning, everyone. So Yang has talked really nice about fires in continental US. We found that the fire in Fairbanks has needs a little bit more attention. So we formed a team a couple of years ago with couple of folks at University of Alaska Fairbanks, and we've been collaborating with Jun Wang at University of Iowa, and also had a hire from Naval Research Laboratory, also Kwan Gupta from URSA, and recently we've been expanding our team with working with health folks, including Micah Han from UA and Loretta Meekley from Harvard. And we also have stakeholders from local agency at you. I heard from Eric yesterday. He gave a very nice talk about Fairbanks fire, and they have a very large agency doing fire management called AICC, and we also have another team doing kind of GIS system. So we're trying to, what we're trying to do is that we're trying to improve the air quality forecast during Fairbanks fire season. Because in fact, actually, for example, this year, Abby, I was talking to Abby earlier today, and Fairbanks was burying fire smoke for months this earliest summer, and the last year actually even longer term. So we've been suffering really badly from wildfire, and this something has to be improved. So we have started a few things. First thing we're working on right now, we're trying to develop a multi-model, multi-AOT ensemble correction approach. So we're using a couple models, including GLSCAM, WorkCam, and the CMAC, as well as using a couple satellite products. We're trying to provide a computational fast and economical method that has potential to be used by local air quality agencies. So this was mainly based upon the work done by University of Iowa, that they came up with two parts to do this called common filter technique to improve the air quality forecast. They're using local surface observations and as well as satellite AOD. So we're kind of implementing this technique into Alaska. And so the main idea is that you have model prediction, then you calculate the error covariance, and then you correcting your model from each step with input from observations, and then you are in fact improving your model prediction by including information from observations. So this technique has been we are currently testing this technique for Alaska right now, and so we done some case study. So this was a picture from earlier this year. As you can see, Alaska was buried in the smoke, and we got lots of hotspots from fire. And this was for a period in July, from July 1st to July 13th. Also, another thing, actually, kind of our large obstacle is that we do not have much ground-based measurements. So we start to use purple air sensor data as a way to give us some more information. Because in fact, we only got like 6 sites across the whole state from EPA. So that was definitely insufficient. And we start using purple air data, and with purple air, we had about 140 purple air sensors in Alaska, and we think this can provide more information. And we actually did some correction following EPA recommendation for purple air data, and then try to include this information into common filter. So basically, what we found is that so this is purple air sensors across state, and you can still see many parts of Alaska. They're not even purple air sensors. So what we found is that, well, we're including this model. We were just testing this. We're using GLCF model, and this is the one comparing GLCF with purple air data. And then after we including common filter, we found that we can improve the model prediction slightly, a little bit. And this is something we're still trying to do a little better job. We think that if we include satellite AOD, we might be able to do an even better job on this, but this is something we're still testing right now. So this hopefully we will have a near real-time air quality forecast in Alaska during wildfire season in next year. This is our goal. So our next topic is that, well, this is just using one technique, and our next topic is that we're hoping that we can develop a AOD PM2.5 relationship during wildfire season. And so we are we first start to using GLSCAN model as a way to interpret this relationship between AOD and the PM2.5. But we found that actually the relationship from GLSCAN model is far off compared to observation data and observation AOD and the surface side. That's just not good enough. So we're trying to do some correction. We're including some data from Calypso as well as real-time AOD and the surface PM2.5 data. So we're trying to do a couple corrections for this relationship, this 2D relationship, and then we apply this relationship to the data from WIRS and from MODIS. So that's our goal, and then we can come up with a satellite-derived PM2.5 and compare that with purple air sensor. So so basically, so what we found is that is particularly once there's a heavy wildfire smoke model which is far off. This was original relationship between AOD and the PM2.5. This we call eta, and this is far off and compared to observation. So we trying to do some correction. We correcting model, one based on observational data set, one based on Calypso data set, and then we can really try to reduce eta as much as we can based on observational constraints. And what we found is that, so this was original prediction satellite derived PM2.5 using satellite AOD. We found that the satellite derived AOD is way too high compared to surface observations. And after we've done a couple corrections, this is the first correction we're using observational data set, but there are only a few sites allow us to do this correction, and we kind of extrapolate that was not good enough. And later on, we found that once we use Calypso data, we can do a better prediction during the wildfire season. So this is something we're still working on. And the third thing I want to talk a little bit is that this is a little bit off topic, is that we start getting more interested in the whole Arctic Circle, that we are not doing we originally were trying to understand about biosphere atmosphere interaction, but then when we start looking at something called formaldehyde in the Arctic Circle, and we're looking at two satellite products from OMI and AMS, and for the past 15 years, and we actually reprocessed data, and we actually had a paper published this year to show that actually for formaldehyde in Arctic region, the main driver is not biogenic, it's actually wildfire. Wildfire is the main driver for formaldehyde. As a matter of fact, wildfire directly emits formaldehyde a lot more effectively than biogenic production from ice cream. So, and then we start to pay more attention to formaldehyde in Arctic Circle. And then we run model for past 15 years. We're looking at the satellite record for past 15 years. Then we dive into each individual region because each region has different vegetation type or different drivers. So we're split Arctic Circle into 4 regions: Alaska, North Canada, Siberia, and Eastern Europe. And what we found is okay. And let me just show you first of all, it's a record for the past 15 years over Siberia, Alaska, and North America and Eastern Europe compared to satellite records. And the red line is just come with vertical column density, and the blue and the cyan line are from OMI and AMS. They agree relatively pretty well, and so tells us, okay, our model and the satellite Z actually show pretty good agreement over the past 15 years. And then we start diving into the driver for, okay, what's driving the interannual variability? And what we found is that, let me just show you a little bit. The blue color is from the background, from formaldehyde. The background is actually very high. Background is methane oxidation. And the green color is from biogenic production. You can see that in different regions, biogenic production give you different amount of formaldehyde. And then you start seeing that this red color is from wildfire. You can see that the interannual variability is in fact driven by the wildfire emission, and because the whole Arctic Circle, they have very strong interannual variability, and we found that it's driven by wildfire. And another evidence we start looking at another product is called solar-induced fluorescence from OCO2 and the tropomi. And the solar-induced fluorescence showing you that very stable interannual variability of biogenic activity. So basically, we are getting from that is that the strong interannual variability is driven by wildfires, not driven by biosphere. So with that, I will just talk a little bit about our ongoing collaboration. We're trying to implement our air quality forecast into an ArcGIS system with our local agencies, and we're also trying to examine the health impact of Alaska wildfire smoke over the past 20 years with Micah and Loretta, and we are also trying to improve model forecasts. And also one last thing, I would encourage you to check Megan Christian's flash talk, and from University of Iowa, they actually have some new products about wildfire smoke. Okay, with that, thank you very much.
I think wonderful, interesting talks. We can really start to see the interconnections between them. I think Mary, I'm going to call a bit of an oddball and ask you to come. And then just to give our Mission Impossible person a little bit more time. So, what's the state Air Resources Council?
Okay. Very good. Well, the last 2 talks, great stuff, great work that's going on to assist in this sort of impossible problem of Western wildfire smoke. As Jan said, the Western wildfire season is now extending from February, well, a lot of years until December. So we really only have like a month and a half where we're not in wildfire season, although somewhat thankfully, different parts of the West see wildfire smoke at different times of that almost year-long season. I guess. Oh, okay. All right, there we go. Okay, Westar region. We are 15 Western states, the 15 westernmost states. If you think about an area from Alaska down to New Mexico, from the Dakotas over to Hawaii, that's Westar region. The Westar region is 24% of the US population, but 50% of the US land mass. And within that 50% of land mass, it contains 93% of the total federal lands in the US. So Federal lands are very much, something we think about a lot in the West that perhaps folks east of the Mississippi don't think about too much, but it becomes important in many aspects of regulating air quality for the states, the local and the tribal agencies within the Western region. This is what we do. I always start off with this because I think people are sometimes confused or wonder what Westar is. We are a service organization. We assist our members in achieving their air quality management goals. We don't have goals of our own. We're directed by the Western states, tribes and local air agencies. We work together on things they want to work on together. And wildfire smoke has become, over the last decade, one of those things that Western states very much want to work on, because there's not a set funding stream for it. States don't get money from the federal government to work on wildfire smoke. It's been a very sort of organic effort among the states, locals and tribes to see how they're going to work with wildfire smoke. And that's why the efforts that we've just seen are so important to the Western states, because there isn't a dedicated funding stream. And so these kinds of things, the questions that the states have are things that need to be answered in order for us to protect people in the West, the health of the people in the West. We provide some training. We also have what's called the Western Regional Air Partnership within Westar. We like to think that the RAP focuses on the technical side of air quality, and the Westar focuses more on the policy side. But to be honest, those things are getting really sort of muddled. So our funding comes mainly from the EPA. We do get funding from other federal land management agencies. Sometimes we get funding directly from states to work on projects. We communicate with the states through all of the MJOs. They're sister organizations like Westar throughout the United States, and we work together with those organizations to tackle technical issues, including what I've listed here, the Federal State Technical Work Collaboration Group. That group's particularly focused on looking at improving emissions inventories throughout the country. Here's a look at how the multi-jurisdictional organizations are broken up throughout the country. So you can see Westar RAP in the West, then Sincera, LADCO, Metro Force CESARM, Marama, and NESPOM. So every state in the country is covered, and local agencies and tribal agencies join some of those groups. I think Westar RAP has the largest participation of local and tribal agencies of all the MJOs. So talking about wildfire, this is just this fall, just a satellite picture that I particularly liked. I suppose I have sort of a library of these kinds of pictures. Often I'm talking about wildfire smoke and how it affects various air quality issues, sort of the federal mandates that Western states have to work on, like meeting the National Ambient Air Quality Standards for fine particulate matter, meeting National Ambient Air Quality Standards for ozone, the regional haze rule, those kinds of things. But in the end, it really is about protecting public health. And this is a picture we had a fall meeting in Missoula, Montana, and flying home back to Santa Fe, New Mexico, where I am located. I looked out the window and caught this. This is that a multiple wildfire event, mostly centered in Idaho, but I was a little bit over, I think probably right about over Logan, Utah, on September 9th, flying and caught this picture of the smoke, which sometimes we think this is the clouds, but it was indeed smoke. So what happens for state agencies when there is a wildfire event? The really important thing is that real-time communication with the public about the smoke impacts, and making sure that that the monitors are working and that we can make those communications happen. More and more communities that may be impacted, we're seeing over the past decade, more and more large urban areas being impacted. That wasn't something that states had to deal with. I think just 3 years ago, the city of Portland was inundated with smoke. We were even looking at potential, we were hearing of potential evacuations from the south side of Portland as wildfire encroached upon a major western urban area. We saw the Marshall Fire in the winter on the north side of Denver, similar thing. Some of the questions that states are asking because of this sort of intrusion of wildfire into the urban areas, as more and more homes are burned, what is in the plume, what's the chemistry, what about toxics, what about burning toxics, how long will the smoke last is something that citizens are always calling state, local and tribal air agencies and asking them. State, local, tribal air agencies more frequently in the past decade have gotten involved in recommendations for curtailing activity, and decisions about keeping kids inside instead of sending them out to recess. There's a lot of activity to monitor indoor areas. We know now that that recommendation that was maybe made in the past, 10 years ago to let's just have everyone stay inside. Now we know that some of our indoor areas are become just as smoky as the outdoor areas. With the advent of more monitoring, we're finding out a lot more. But anyway, those are some of the things that in the short term, while the event is going on, and some of the events are longer in duration than they were, say, 15, 20 years ago. We're talking about multiple days, chronic exposure to wildfire smoke, and what does that mean for the public? So after that short-term response, and we have to think about the state agencies need to think about the long-term response, flagging and analysis of the data, exceptional events. I think Jay Baker talked about exceptional events yesterday. Working with EPA, we're now seeing litigation in our court system over these exceptional events demonstrations that states are submitting. So there's a lot of work going on there too that again is really groundbreaking sort of things that are not within the template of regulating air quality that state, tribal, and local air agencies are working on. So how can satellite data help with all of this? Of course, satellite data has been foundational for that conceptual model. Looking at the NACs and other air quality issues, satellite data has been and will continue to be into the future very important for that analysis, as it is for exceptional events. The entire demonstration that states have to submit to the EPA that, as we're seeing, needs to be defended in court. Satellite data is a great complementary part of those demonstrations, analyzing dust events. The wildfire smoke analysis and forecasting, we're seeing more and more states creating smoke blogs to communicate with the public. Satellite pictures are very often, you can almost say like there aren't very many of those smoke blogs where you don't see a state pulling a satellite data picture and putting that up to the public, because as we all know, pictures are a great way of communicating. Emissions inventory development for smoke, for mobile sources, for oil and gas, all of these things are satellite data can help us inform those, improve our inventories. Looking at air toxics, really important, becoming very, very important. Informing the transport of air pollutants, evaluating and improving our meteorological and photochemical model performance. We've heard a lot about that over these past couple of days. And then finally, rural areas of the West that we saw in Alaska, very sparse monitor coverage. What can we learn about what's going on in air quality? from satellite data where we don't have monitoring. And we may not even have a great ability to model those areas because of the lack of monitoring. We can't evaluate model performance. So, that's all I have. This is actually part of that smoke event in Idaho, Western Washington, where we saw a couple days in September of unhealthy to very unhealthy air quality in Seattle and Vancouver, British Columbia. Thank you.
Wonderful. I'm gonna assume the person standing up is our next speaker. Or they have to use the restroom, which is also fun. Thanks for. We can start to see how these talks are putting together. Just as a reminder, we're holding questions and our esteemed speakers come up. We'll take questions from the audience and online. So
I have.
I may have you say your name. but-
Yes. You can say it, Amir.
Amir from IQAir.
Amir, yeah. Yes.
Okay, welcome, thank you.
Yes. I guess it's almost afternoon. I want to say, at least for my time, because I'm coming from LA and I was challenged by a late cancellation of my flight. So I took the risk to still make it in person. So it was very on time. So thank you. So I'm here on behalf of IQAir North America. I'm gonna give you an overview of how we as company use satellite data and how we can leverage more data products that are coming out of satellite or different methodologies that being recently implemented between sensor networks and satellite data and how that can help our users to, especially since we are in the health and wildfire session, how they can capitalize on these events using these type of new data products. Our company is founded in 1963, and I would say our key areas of competence would be air quality information technology, basically our platform that I'll go over in a minute. Our air monitoring technologies, our sensors, and of course the visualization, the communication platform that we provide. We believe in this model. Basically, everything comes from the data, the impact, and we are in between. Basically, we try to prepare information. We are using knowledge, so they're a knowledge-based company. And then we are definitely believing in insight and wisdom being the driven of this efforts. We use these 4 key of air quality principles in our platform. We start with the 2 at the top, but as everybody else and as all the science is supporting, we are also pushing to the satellite data and the air quality models in the recent years. This is the sensor network that we are currently holding in our data platform. We have data contributors globally. In US, one of the main ones is there now, including Purple Air and our own sensor networks. Of course, the goal is to make all the gray areas either red or blue in this map, or maybe green as a satellite data. So we're just trying to make sure that we are harmonizing all the data and we are not really sacrificing precision and accuracy to whatever that call, to whatever that's the replacement of that. So currently, in terms of the satellite data we are using, we are providing IQAir Earth and IQAir Map. There are 2 links in this that I would appreciate if you could switch to those.
Yep, sorry.
No worries. Simply, we are providing a world map with air quality forecast, fetched from different forecasting systems globally or in the United States. That's IQAir Map. And the other one is IQAir Earth. It's very much looking for some of the products that everybody sees. This is not a globally forecasting system for PM 2.5 and PM 10. One of the NASA data that we would hopefully use is ozone would be something that we would be interested. VOCs are getting interest, so that would be something coming along the way. Can we switch to IQAir map now?
Oh, back to the other one?
Yes.
Yes.
This one, we also provide the sensor network, the concentrations, and basically the corrections that the model runs with the satellite data. As you can see, we have different tabs: air quality stations, fire, map, and then the air quality from the sensor network ground base and the surfaces that are basically harmonized with the satellite data. Can we go back to the slides?
Yes.
Thank you. I appreciate that. The data sources and the multiple forecasted system for different data products are being included in here. So when we are standing in the data quality objectives, because with the bunch of data sources that are coming along, we need to make sure that we are basically providing a methodology or structure to basically fusing all of these data sources scientifically and in a way that our users could leverage. We are holding more than 50,000 air monitors. We need to validate, harmonize, and calibrate all of these sensor networks from different sensor providers. And the next upcoming challenge for us will be basically developing a more, I want to say, precise and accurate methodology and structure to basically fuse near real-time, I want to emphasize, near real-time satellite data that is potentially coming on the way by Maya products, not sure, maybe. So, and then also kind of try to provide some globally acceptable methodologies. That's really hard, but globally acceptable methodologies to mix and fuse the ground-based measurements and satellite data. Because in our platform, being local, which is something that scientifically is available and feasible, would not be satisfactory, at least. Of course, all of these are for an impact, which we are trying to basically provide some clean air solutions. And then, of course, at the end of the day, using our app or website, we are trying to mitigate the exposure. We have partnerships ongoing with UNEP, and then also the Greenpeace. So we have tried to, yeah, exactly. Thank you. I appreciate that. With UNEP, we are in this website, you can see basically the real-time air pollution exposure based on population, based on the number of air quality stations. So the hope of using more updated air quality data coming from satellite is just basically making this number more accurate for real-time exposures. And of course, it would be better for us. We were just in the Air Africa conference. In this area of the world, more than 40% of the countries don't have ground-based measurements. So we are heavily depending on satellite data on those areas. But of course, here comes with the caveat that have we really tried to harmonize that with the ground-based measurements and basically this balance that comes off the way that I guess all of us have been experiencing during this sessions. Can we go to the other one?
Mm-hmm.
Another partnership that we have is tracking the cost of air pollution with a NGO named Greenpeace that basically we provide the ground-based sensor track-based air quality metrics. Oh, that's the hope that we can get even further resolution on a kilometer basis or 10 kilometer or maybe even like surface based. So those are all the data products that will be helpful for us to leverage for our users, for our partners, to better characterize different metrics that are important when we are tackling the air pollution problem. Awesome. I'm representing the air quality science team. We are trying to engage with the regulatory, scientific, and given that we have all the academic background, we're trying to basically engage with all the stakeholders in the game of air quality mitigation. And we are basically calling for collaboration and calling for keeping the channel open And that's why I basically take the risk and make it personal, in person here. Thank you very much. Please let me know if you have any questions.
Thanks, Mary. If you don't mind staying up, we'll have the panel join you.
Oh, yeah, sure.
And then.
Yes.
And then thanks to Rachel for navigating. Um, We have, as with previous sessions, we have a good checklist, which we appreciate, to really dig into some questions. So I'm happy to take them.
Nobody else has one out. Do we need a microphone or mine is gonna be minor? Whatever you want. I'm not asking.
Here you go.
I think I've run out.
Thank you for this panel, and I see how you're all coming together. I love how the work is developing in Alaska. It's just amazing. I want to hear more about that in person. I'd like to know more about your products. Mary, I always love your work. I mean, it's such a big region, and you're on the cutting edge of everything, it seems like. So Yanglu, I was wondering, like, I noticed one place, and you are on the cutting edge, but in the Appalachian and the Alleghenies, it looked like there was a lot of high percentage of PM and from fires. The attribution was from fires. I didn't quite understand that one. Could you help me with that? And as a secondary question, I think for everyone, I asked it yesterday and it seemed to get a good response. I'm going to ask it again. If you had anything you wanted that you could say, I want this big thing, their money's not an objective, or what kind of goal, what do you want right now that would take us all forward for stakeholders, for yourselves?
Thanks, Amber, for the question. I'm curious about that as well. Along the Appalachian, we have elevated PM levels. I'm not sure if that is 100% from wildfire, from something else. But I promise I'll look into it. But for now, I don't have a straight answer to that.
Yeah, I even looked up, so maybe I remember the wrong year, 2016 for the fires in Tennessee, and I looked it up, it's like, no, it's 2016, it's not that, because that was 2018.
It's 2018, yeah.
And now your wish list. Well, what do you want that would help you satisfy your stakeholders?
My stakeholders?
Yeah.
Good. Well,
You can pass and think about it.
let me think about it. Mary.
I'll say right away, an air purifier in every home in the West would be it. But
Why
but
just the West?
well, yeah, maybe the East too. Yeah, an air purifier everywhere. That should just be a right of citizenship in the country. But at any rate, I think there are so many questions we have, as I said. I think there's some research coming out looking at health impacts of wildfire smoke versus PM 2.5. Is wildfire smoke, is it more, does it impact health in a different way than PM 2.5? A lot of our studies have been with urban PM 2.5. What's the difference between that for health impacts? But as far as satellite data things go, because we're here to talk about that, I think more support for state, local, and particularly tribal agencies. If we could just support those agencies in the use of satellite data more. I mean, there are some great things out there. There are wonderful guides, there are wonderful videos that are out there to learn how to do this. But in the end, we know that our state, local, and tribal agencies have expertise in looking at air quality problems. Their problem is capacity. So more support, really.
Okay, I'll take, I guess I'm next. I actually have two things I am hoping for. One is that, I'm hoping that there will be a great air quality forecast product that we can use, particularly in Alaska, that a lot of people suffering from, they don't know what's gonna do once we're bearing smoke for months. And they just need really good guidance about air quality forecast. Another thing, actually, I was really enjoying your talk is that I think some like communication stuff to the public, because public, they just don't know where to get that information from. That's something we've been struggling in the past. That public, where would it go? They actually just have no idea. And with the maybe cell phone app, they can incorporate some air quality forecasts. It can provide them guidance for them how to figure out to mitigate, wildfire smoke pollution and plan their activity accordingly. Those kind of things that I think public need very badly. That's my feeling in Alaska, because once I'm on Twitter, once we have wild smoke, everyone is just yelling, and the people, but they don't know what to do from there. They just have to stay at home. But if we have a way to share with them, okay, here's maybe you will have wildfire smoke for next day or two, and this is what it's gonna look like next week-ish. People really can figure out a way to mitigate that effect. I think that's something I really hope.
Yeah, so I guess basically what we would need as a company in terms of the data, of course, as near real time as we can get with the satellite data would be something satisfactory. But I would code the forecasting system because to close the loop of notification when special events happen in the air quality, you would need immediate actions, right? And then we as, I want to say notification system, I don't want to call ourselves the app or whatever. This is a notification system that we could basically communicate with the users. There are plenty of good data products that sometimes they're just getting on the shadow and they're not getting used or serving the purpose that why they are being developed. And what we are trying to do is just kind of leverage the data products in a way that they could serve a purpose either for a user, either for a partner that we are working with and again, not only in litigation of air quality, but also in the health part, policy part, if we can, by like we are in the Clean Air Coalition board as well. So we are trying to basically push things on the policy side too with the data products. But I guess the one thing that would also help this is just maybe communicating with, like, support is a good word, but maybe to keeping the communication channel open so that there's a like with what we need, for example, what stakeholders need, they could go back, talk, and then kind of this feedback loop could persistently be there, other than just, for example, one time a year meeting that could come up here and talk about what we have, what we don't have, and then go next year and come back and say this was kind of basically closing the gaps of communications.
We actually have a couple of questions in the chat, so I'm going to ask one of those and then we'll go to you. To Yang Lu, how do you distinguish wildfire smoke from agriculture or prescribed burn smoke?
That's a good question. Prescribed burn and agricultural waste burning are very difficult to quantify. Number one, for the prescribed burns, the records are kept at the state level, and they don't really talk to each other. You can get prescribed burn permits from like forest commissions, but it's the upper limit as to how much you can burn. Actually, how much was burned, nobody actually knew. Right. So from the satellite perspective, I think it's a kind of a natural selection currently in our model system, because they tend to be small. They tend to be a lot cooler than forest fires. Satellites just simply don't pick them up. They can't see them. I mean, that said, in the Southeast, for example, the prescribed burning is a serious concern. It burns tens of thousands of times every year. We got to have some way to characterize that. Currently, I don't have that. Right? Probably, I think that question might be better answered by guys like Ted Russell, who's been doing that for maybe a decade. We're trying to figure out how to factor, how to better inventory prescribed burns. But for me, it's just that the model skips that step.
Great talks, everyone. I do like how they all were very symbiotic. But Jingqiu and Amir, your maps really kind of illustrated that there are places in Alaska, on the earth, that are missing in terms of air quality. And I know how important those monitors are for ground truthing our satellite data. And it seems like we're creating another potentially digital divide of places that have monitoring capacities versus don't. And Yang and Mary, your maps also show places in the Mountain West, especially that may not be populated, but are definitely impacted, or may not be heavily populated, but are definitely impacted by smoke. Do you know any initiatives, or kind of in light of Amber's question, where are there opportunities to increase monitoring, especially ground-based monitoring, in places that we don't already have, because those places also tend to be places where there are EPA monitors already in the US, or that these are higher SCS populations potentially that have capacity to mitigate while other populations don't. So do you know any initiatives to kind of improve the ground-based monitoring network?
I can talk about, for the West, just over the past couple of years, the use by state, local, tribal agencies of low-cost sensors is exploding. I think even like 3 or 4 years ago, state of California was purchasing hundreds. So those are being deployed all over by not only the states, locals, and tribes, but then other organizations as well are deploying them. I have a purple air monitor at my house now. You know, it's not that unusual of a thing. So I think we're the Fire Air Now map incorporates all that purple air monitor. So when you pull up that map, you can see air quality at my house from the wildfire smoke or anywhere really, and I can see where there used to be huge data gaps. Now we have some ideas. Of course, there are issues with the sensors. They're not they're not calibrated, always. And on mine, spiders crawl in, and then I don't get data for a little bit until I get the spider out. And there are those kinds of things that are going to be an issue. But I think the low cost sensors are just really, it's incredible what's happening. I don't know that that's happening all over the world, but
yeah, I was actually going to say, maybe sometimes they're like overpopulated with these low cost sensors now after 2000. I want to say that bold, but that's actually the case in developed countries, I want to say. But of course, when we were talking, as I said, like in the Air Africa conference, all the talks were about data gaps on ground-based measurements. I know there's not a lot of, that's a misspoke. There are funding sources trying to fill up the data gaps. We are preparing a framework to make sure that we can fund the projects by deploying sensors in Africa. Dan Westerwald, I guess everybody most probably knows his name, with the CAMSNet campaign. I'm sure in the next couple of years, we will have a lot of good progress in the ground-based measurements as well. So yes, there are works being done, but of course there are heterogeneities everywhere. So
Yeah, I'd like to point out some challenges, because actually a couple of years ago, I was trying to install like 30 sensors across Alaska, have one question. But turns out that the main challenge is not installation, is maintaining those sensors. So you need Wi-Fi, you need power, and particularly when we're trying to install those tribes in Alaska, we had to have started really talking to them for a lot before we can do that. And then once we install those sensors, some kids will unplug the sensor to charge their cell phone because the resource often limited in those tribes. And we face a lot of challenges. And then we realized actually the main cost is coming from human labor to maintain those sensors. And this is something I don't think they have been addressed adequately in lots of proposals. And people saying, oh, we can install 200, but that's it. And no one ever talked about the potential cost of hidden costs. I would say that maintain those and really, I think this should maybe something NASA, maybe like citizen science, NASA has lots of initiatives about this. And maybe something could think maybe funding towards those understudied regions, maintain those resources. I think those are very valuable, as you can see, but we do not have those data if we do not maintain them.
We may go back and forth chat to the room, but
Okay, next question from the chat is for the wildfire PM 2.5 estimates. There have been some cases of high wind events causing dust storms and wildfires. Is there a way to separate dust and fire contributions when the dust may not be affecting background PM areas?
Yeah, that's another good question. A couple of years back, we did some CMAX simulation exercises to see if dust emissions will actually interfere with CMAX simulation results. The initial findings are their dust events are not interfering with fire smoke simulations. And that's why we kind of trust the smoke only CMAX simulation results as not being interfered by any dust events. So in the model, the HMS contours are not affected by dust events. CMAX simulations are not affected by dust event. Therefore, the dust model, aside from, well, AOD is not really affected by dust because the particles are generally less sensitive and bigger than PM 2.5. Right? So I say on the model input side, we are reasonably immune to the interference of dust events, right? So I don't, at this point, unless we're talking about, Daniel Tone's dust events, cross interstate level dust events, I don't think it's a big source of error in our model. Yeah.
Was there one after? There's one here and then.
Hi, I'm Caitlin. I work for the Wisconsin DNR, just over up the road. As a regulatory agency, we have FEM and FRM regulatory monitors. Some of the things that we've noticed in using the applications that have model-based values are discrepancies when we're standing at a site, reading current values, and obviously there are times where the air quality is in the good range, but the model is showing, moderate or whatever range. And additionally, all of you have actually mentioned low-cost sensors, but as we all know, low-cost sensors have limitations, especially in regions of high humidity. And so I kind of want to hear a little bit more about considerations of correction factors associated with those low-cost sensors, and then also the ability to use more like column research in understanding the association of satellite and ground-based models and measurements.
You're absolutely right. So in terms of purple air, there are quite a few studies to think about calibrating purple air data to get close to FRM or FEM monitors, and it doesn't have a a size cut. It's not thermal-regulated. It's not dehumidified. These factors affect its quality dramatically. But the way I see this is you have to, at least from my perspective, you have to treat sensor data as big data. So every data point is very noisy. There might be even systematic drift. But the power in the low-cost sensor is its volume. It's how you aggregate them, turn those, we call it weak learners, you put them together as a group, as a population, it becomes a very strong learner and reveals information that the regulatory network can never reveal. So I think it requires, it's hard for regulatory agencies, right? Because you can get sued if you say that. If you say, well, that measurement there's an error bar associated with that. I don't know exactly where it is. But on the research side, we have I think, at least I have a different mentality when I look at prepared data. I'm happy when they're good enough, because just the sheer volume, the information buried in that noisy data is very valuable if we have ways to distill it out. But for you guys, it can be tricky. Yeah, I know that. Yeah.
Yeah. Yeah. So I guess in terms of, it's just, there's this, what the data quality objective are we trying to achieve is the question. In Africa, when we don't have any measurements, not FRM, FEM, in more than 50% of the countries, accuracy is in your second level of priority. Reading something with our R2 value of 0.7 is gem in Africa, right? So what I'm trying to say is that in California, for example, with all the studies coming out from 2017, you have a pretty good confidence with even with the satellite data fusion, sensor network, and regulatory monitor. But in Africa, for example, that's going to come along in the next, I want to say 5, 6, maybe 10 years. So it's just the data quality objectives that needs to be defined at the beginning of each project. If you're talking regulatory, I'm coming from a sensor company. I hardly see sensor network playing a major role in the regulatory policy in the long run, unless something very magical happens in terms of the sensor technology. But how we can expand on monitoring, that's a different story. Like I'm coming from LA. Warehouse emissions around San Bernardino was a myth for everyone, unless you do a source apportionment with air quality monitors in San Bernardino, Central LA, Long Beach. And I have done some source apportionment studies during my PhD, and that was like taking 5 years of data from like 5 station monitors. Now, if you fetch 1 hour data from Purple Air or 1 hour data from our website, you will, in rush hour, you will just potentially see some effects of warehouses of Amazon in the San Bernardino airport area. So what I'm trying to say is that they're basically trying to serve different purposes, and mixing them up is just going to be not helpful, I want to say. We just need to know what are we trying to achieve with what. Like with this, we are with our application, we are not trying to say that this is what users need to be depending on a regulatory grade, because it does have regulatory grade data inside fused in, but it does not serve the same quality, of course. But does it help our users to take actions, to know what they need to do in terms of the mitigating the exposure when there's a special event? I would say fairly yes.
I would add to that is that there are also some information. Once you have enough local sensors, the spatial correlation is often a very useful piece of information. Because give you one example, when we were burying the smoke in summer, I often look at like 30, 40 sensors in this like 3 kilometer area. They're all showing similar numbers, and they change like within 5%. So we tell you, even if they're relative, there might be some bias, but relative trends for those sensors, and they agree amazingly well. And just that seems to me that's a piece of information that can help us to improve model performance. So even there could be bias among all of them, but the relative change and the spatial correlation, that part is just really great. That's something I think can be taken into account for model evaluation.
Yeah, I'll just add that federal equivalent and federal reference is for the general public a very, even that is really difficult to discern and understand. Non-attainment is another term that we use pretty freely in the air quality in the regulatory world, that when it really comes down to it, becomes very difficult for the public to understand as are exceptional events. I think I've heard the general public say, what do you mean you're throwing out data? What do you mean you're not using that data? Or, I think there's a lot of perceptions, and it is great to have things like Fire Air Now or the Air Now map, where people can just go and because in the end, what people want to know is, should I go for a run now? Should I go for a walk now? Is my dog going to be safe in the wildfire smoke? And of course, the maps don't tell us exactly that, but they give us somewhat of an idea. So, yeah.
And just add to that about the messaging and then the information needed to convey to the public. I think last year I was asked by a reporter, should I go out and exercise when there's smoke in the air? You would think the answer is straightforward, but I'm going to argue there actually is no science to back one way or another. Actually, there was a study out of Hong Kong on the long-term effect of exercising during pollution for your cardiovascular health. The health outweighs the risks. So the conclusion, that's kind of crazy, is go out and run. It's an episode, right? It's like insane. How do you convey that? Public health agency, how do you convey that message to the general public? It's tough. And on the other side, we saw during from our study in Colorado, the smoke per se somehow, for some reason, is way more toxic than the ambient PM. For example, for asthma, I think the effect is actually at least 3 times stronger. Meaning, if the perception we derive is based on ambient pollution, that perception is actually wrong. Even the scientific conclusion does not apply during a true smoke event, right? Because somehow smoke has a pretty different composition and differential toxicity than ambient pollution. And then say, should I run when there's a lot of smoke in the air, or versus when there's haze in the air? That question remains to be answered, right? So I see there's a great sense of urgency as we see those huge fires in the satellite imagery, but that unfortunately the health side of study is actually lacking. It's surprisingly lacking.
Sorry, I'll work harder.
So for epidemiologists and for us in the school of public health, it's like we got to work on this. We have to work on this, right?
Yeah. There are 2 that I'm on the hook for already. So if you would indulge me to stay, we're at time, welcome to get up and leave now. But I already committed to 2 questions, which have to be our last ones. So one here and then one there, but if we could keep it under 5 minutes, that'd be wonderful.
Mine is quick, so
Yeah.
I wonder even, because you mentioned that, there's an overpopulated low-cost sensors. I wonder even low-cost sensors tend to overpopulate in more affluent areas. Because $250, we call them low-cost sensors, but they are still expensive by according to many other people.
Yeah, just to make the answer very short, I guess different grants that was out to leverage different affluent communities like 535 communities or maybe 670 communities. At least maybe focusing all of my discussions in California because that's all that I'm more familiar with. Those were the communities that were actually increased the population of purple areas in many ways. I did a study in 2020 that seeing where we should put the next purple air in California. And it just showed that while there are still disadvantaged communities that need population exposure monitoring, and there are actually some very high concentration areas that are not necessarily in the affluent communities anymore that need exposure measurement or exposure monitoring. So returning to that, of course, we need to know what is enough. That's my answer.
Well, and the Inflation Reduction Act is going to
Yes.
change that too, because there's a lot of money within that. I mean, we don't know exactly how that's going to play out, but states are going to be getting money for environmental justice work. And I suspect that many states are going to use it to put sensors in communities where there aren't a lot of sensors.
Okay, so quick question. I think this is too for IQAir. So first of all, really cool animations and cool visualization you have on your website. So you mentioned about satellite data. I was just wondering if you can get us a little bit more detail what satellite data you're using and how they are actually helping in improving accuracies. If you can give me some example, that will be nice. And one last comment on, you mentioned in your talk, you want to use ozone data from satellites. So I just want to say that there's no ozone data for surface pollution from satellite. So if just want to make sure there is ozone data, but it's for the column, entire column. This for surface. So far, we are not able to pick that.
Yes.
Thank you.
So I guess to keep the technical part of it very, I want to say short because I see that there's some. Basically, we are using two forms of data from satellite data or mechanisms from satellite. One of them is the forecasting system, the IQAir Earth that I just showed you. That's global. We are not only using some NASA data, but we are using some global forecasting systems. When the data is not available from one source, we are basically using different sources to make sure that we have data availability all over the board and all over the time. In terms of the air quality harmonization that I mentioned, that is an ongoing work. Basically, we're trying to make it better and better, but using the 24-hour estimate PM 2.5 involved in with our hourly sensor-based or regulatory monitor measurements. Actually, one of the main reasons that I'm here is to just make sure that we are developing or we are following a methodology that's scientifically sound, and it's kind of backed by scientific community, because we are a science team, but we want to make sure that we are also hearing different perspectives from satellite people, from sensor network people, so that we are not doing anything wrong. I would be happy to discuss this more as well. Sure.
Thank you. Let's give a last